Today we're going to look at an idea called cumulative frequency, and this is meant to be a revision lesson, and assuming you've sort of seen it before at GCC, but if you haven't, then hopefully I'm going through it in enough depth for you to understand and get your head around it. So the first thing to say, I suppose, is before I actually talk any more about it, is what is cumulative frequency? And if you've seen it before, I want you to think back, like how would you write down a definition? If you've not seen it, then I guess just watch on. Or having said that, like sometimes we do talk about cumulative things, and it's like things adding up together. And essentially, cumulative frequency is essentially a running total. So how do I track that? Well, I've got a grouped frequency table, and I've got 5 things in 0 to 10, 8 things in 10 to 20, and so on. How can I keep a running total? By the way, this is for an airport, just a number of late arriving aircraft. Okay, what I could do is I could basically look at the upper class boundary for each one. So in this case, it's going to be 10, because I'm looking at all the values that are less than 10. And then for this one, I'm looking at all the values that are less than 10. So actually, I'm going to write, even though the upper class boundary is technically 10, I'm interested in all the values that are less than 10. And I've still got 5 here. But for the next one, I'm now going to be interested in all the values that are less than 20. And now I've got the 8 values here between 10 and 20, but I still have the 5 values. So I'm actually adding it together. So I get 13. The next one, I'm going to be looking at less than 30. And now I've got all the values that I had before, but I'm also going to add 22. So that's going to give me 35. And I'm creating essentially a little table for cumulative frequency that's going to be useful. It's keeping track of the running total. This is going to be less than 40, and you should try and finish it off yourself. 47. Less than 50 is going to be 55. Less than 60, therefore, is going to be 60, which is the total frequency. How can we use that? We can actually plot it on a graph. So how do we do this? Well, we basically plot the upper class boundary against the cumulative frequency. So I'm first of all just going to need to grab this table and bring it down. Actually, I need a bit. No, that's all I need. Okay, and I've already drawn the axes for you. And what we do is we plot the upper class boundary against the cumulative frequency. So I'm going to plot 10 is the upper class boundary, first of all, and then I'm going to plot it against 5, just a little cross. That cross is telling me, when I look at it, that I've got 5 people. Sorry, it's not 5 people, is it? It's 5 planes that were less than 10 minutes late. That's how I interpret the result. And then I'll do the rest of them. So for 20, I'll plot 13. So it's going to be about here. You can only do it approximately when you don't have an easy scale to work with. For 30, it's going to be 35. Just got to make sure you're really careful. So it's the upper class boundary that's 30, and then it's 35 that's actually the cumulative frequency. 40, we've got 47. That's going to be about here. 50, we've got 55. And then 60, we've got 60. There's one other point that we can use, and it's actually the lower class boundary of your starting group. In this case, it's 0. It won't always be 0. This graph won't always start at 0. But in this case, it does. So I'm just going to add that one in red. It's like a special case where I'm using the lower class boundary. What do we then do? We have to join it up. Now, you can actually technically join this up with a straight line. There's nothing wrong with that. So if you're not very good at drawing like curves that go through points, go for it. But you'll more commonly see a curve that kind of just fits the line as you might expect. But it is, a biased thing. You're just doing what you think it's going to be. So let me join it up. And technically, I can even carry the curve along, and that shows me that my maximum frequency is 60. So that would be how I'd complete this cumulative frequency graph. I can get rid of the table now. Okay, the table is useful, but I've got an even more useful thing now, because I don't just have these endpoints. I can start looking at other values, like how many planes were later than 20. Well, I have to rely on this cross, but once I've got my graph, I can look at how many planes are less than 25, and that's what we're going to do now. So we can interpret cumulative frequency graphs, and we can these are estimates really, because we don't know that it's going to make this nice smooth trajectory upwards. We're assuming that's the case, but it's still a reasonable estimate to make. So the number of aircraft arriving less than 45 minutes late. Right, that is going to be this position on the curve, because I can go, actually let me do a different color, sorry, I'm going to do red. And really you should use just a pencil at this point. All of this should be done in pencil, it should be said. I'll do it in black, and then I'm going to do a vertical line going up from 45 and then along, and read off really carefully. So I think that will be 52. Yours might vary slightly, that's absolutely fine. So yeah, I basically measured this distance here, and that's what the cumulative frequency graph has given me, the amount of planes that are less than the minutes late that I'm interested in. Whereas the number of aircraft arriving more than 25 minutes late, so I'm going to do a very similar thing. I'll do this in purple, this one. 25 minutes late. Okay, read off. That looks like it's about 23. However, it's this distance that's 23. And in this case, I want the number of aircraft arriving more than 25 minutes late. So it's going to be the total frequency minus 23. That's less than. So it's going to be the rest of it, and I'm going to get 37. Just going to compare the answers to some that that were done elsewhere. Whoops. 52 agreed with me. Okay, they read off the graph as 24. I can see why they might have done that, but I think 24 or 23 would be acceptable. So yeah, 36, 37, that kind of range. Right, from now on, we're going to interpret some more cumulative frequency graphs, bringing in a few other ideas into it. So I'd like you to pause the video and try these questions here. All right, the first one, use the graph to find the number of students who got less than 55 marks. By definition, that is whatever, that's what the graph is telling us essentially. So here where I've got my cursor, it goes exactly through the corner of a square. So it's going to be that 25 people got less than or equal to 25 marks. But we're interested in how many got less than 55 marks, so I'm going to read off from 55. I'm going to draw a line up, and then I'm going to read along. 55 is here, 57.5 would be exactly halfway. It goes a bit beyond, so I think the answer to this is 58. And then I want the pass mark if 3/4 of the students passed the test. But we need to be careful here, because remember, the cumulative frequency graph tells us the number less than, who got less than the number of marks. So if 3/4 passed the test, that means 1/4 failed. And I need to find that position where the 1/4 of the students are getting a certain mark, and hence that will be the pass mark. So 1/4 of 60, because remember, that's the total frequency, is equal to 15. I'm going to have that 15 failed. So now I'm looking for the mark where basically the 15th person is. I can read along from here. It's a bit over 20. I think we're looking at 21 in this case. Okay, let me check with some other answers that I did earlier, and looking good. So just be careful. I think this one's quite easy to make a mistake on. Just be careful what it is you are being asked to find and what information you have on your cumulative frequency graph. Right, now we're going to look at the lifetime of some projector bulbs. So we've got a total frequency of 120. We've got the cumulative frequency graph drawn. Use the graph to find the number of bulbs that had a lifetime of between 200 and 400 hours. So in this case, and again, hopefully you paused the video and tried this. Let's go for it. Right, I can find out how many had less than 400 hours by reading off. Okay, this time it's going up in tens, so I need to be a bit careful. This is going to be, I think, 86. So 86 bulbs had a lifetime less than 400. So what I also need to do is find out how many had a lifetime less than 200 and subtract them. So I think this is about 12. So for A, I'm going with 86 bulbs that are less than 400 minus 12 that are less than 200, and that's going to give me 74. And I just want to say at this point, you know, we could actually we could work back and create an actual grouped frequency table from the cumulative frequency graph. It'd be the opposite process, but I could make a group of 200 to 400, just like I made the cumulative frequency graph by looking at the upper bounds. So I could make a group from 200 to 300, 300 to 400, and so on. And you know, it would be an approximate group because I've lost my raw. Well, I don't have raw data to start with, but I'm interpreting it from my graph with this smooth line. But that could happen, and then you could do things like estimate the mean from an approximate grouped frequency table. After how many hours were 80% of the bulbs dead? Right, so I'm basically looking for the number of hours. Like, it's really important to not rush these questions. The number of hours where I have a certain number of bulbs dead. So first of all, it's a bit different. So this one was 3/4 passing, and I interpreted it as 1/4 failing. So now I can see this is kind of failing as well, can't I? Because that's when the lifetime ends. So I am going to be actually finding 80% of 120. You can use a calculator for this. 10% is going to be 12. 8 times 12 is 96. So I'm finding the lifetime at which the 96 bulb has, yeah, right. So 96, we've got 90, we're going to get a bit above it. I was going to do it in a different color, sorry, bear with me. 90, 96. So before this, like I'd lost some of my bulbs at this point, but the point where I've got 80% of the bulbs dead is going to be here. And I think it's going to be 440, thereabouts. Okay, what was the shortest lifetime of a bulb? Actually, this is quite a quick question. If you remember, I said at the start that we can use the lower point of the grouped frequency table to give us our starting point. In this case, it was 0, but I said it didn't always start at 0. And we can see in this case, it does not start at 0, it actually starts as 100. And that is going to be, that's when the cumulative frequency is 0. It's actually at 100. So the shortest lifetime was 100 hours. Nice. Let's again just check with some I did earlier. So we got good agreement throughout. Pretty pleased with that. Yeah, there might be some you might have done it slightly differently, but it's going to be roughly the same. Okay. What about the median and interquartile range of this data? This is covered at GCC, not in great depth, but it is covered. So I'm going to revise it now, and we will cover these concepts in more detail in lessons to come. Like the way I've made this lesson is I'm teaching it before I've technically done averages and measures of spread. So this is just like a little precursor to that, really. Okay, the median. Let's do part one first, the median. The median is halfway through your data. And we know we've got 120 light bulbs. So it's going to be 120 divided by 2. Now there is a formula to work out the median when you have a list of data. I just want to talk about this. If I had 1, 4, 7, 8, and 10, the median would be 7. Now the median position wouldn't be 5 divided by 2 because that would give me 2.5. I actually have to do 5 plus 1 over 2. You have to add this 1 to get the median position, the third position. That is true in general for a list, and I'll be talking more about that. However, for a grouped frequency table, for a cumulative frequency graph, you don't bother plussing the 1. You can plus the 1. It's not going to really make any difference. I think that's kind of the idea behind it. There's a bit more to it as well. So the median position is, in this case, going to be 60. And I can, again, use the graph to read off 60. So half the bulbs are going to have lifetimes less than this value, and half are going to have lifetimes more than this value. And I think that's pretty much spot on. I think 325 might be too accurate. Like, can I really write it to 3 significant figures? So I'm going to go with 320. But you'd be okay with 325, I think. You'd probably be okay with 330 if it came from your graph that way. And then finally, the interquartile range, sometimes denoted IQR. That is equal to the upper quartile minus the lower quartile. That kind of makes sense. A range is like, you know, the distance between values, and it's actually the distance between the upper quartile and the lower quartile. Now think about what quartile means. It means a quarter. So the lower quartile means a quarter of the way through the data. The median means halfway through the data. The upper quartile means 3/4 of the way through the data. So the lower quartile position it's the position, not the lower quartile itself. That is going to be 120 divided by 4, which is 30. And then the upper quartile position, sorry, that was meant to say 30. The upper quartile position is going to be 3 times that. It's going to be 90. And you can see that I'm going up in quarters every time. So I need to now read off my graph to get that. Let's start with the upper quartile. I did the lower quartile first because I think it's a bit easier to understand. You know, it's a bit easier to understand. Yep, it's a quarter of the way through the data. You just got to realize the upper quartile is in 3/4 of the way through. So I'm going to read off from 30, and that's looking pretty close to, so that's 250. I think it's 270. That was, I just did the, what am I doing? I just did the lower quartile though, so it's going to be something minus 270. Okay, just make sure you don't get them mixed up. You'll spot if you get them mixed up, I think. All right, and then I've got the upper quartile. I'm going to read off from 90. Okay, just read off as accurate as you can. Is this 410 or is it 420? I'm going to go with 420. 20. So what I'm going to get is my interquartile range 150, because what I've actually just measured is this. This is where I've got 60 people, the middle 60 people, or the middle 50% in fact. And then the interquartile range has actually been this distance here that corresponds with it. And that's a useful quantity to know. I know from this graph approximately that the middle 50% of the light bulbs are within 150 hours. The range is 500 hours. The interquartile range, the middle 50% is 150 hours, and that can be very useful. More to follow on that. Have a go at this question here, which is involving comparing cumulative frequency graphs. Now it says draw a cumulative frequency diagram for this data. I would draw an exactly the same one here. I wouldn't draw a fresh graph. Okay, so in this question we're putting together quite a lot of the ideas that we've covered. So the first thing to do is realize that we've got the upper boundaries right here. We're going to have the lower boundary for the first point here. And then I'm interested in the cumulative frequency. So it's going to be 2, then 9, then 24, then 55, and then 60. And I can draw this onto my graph. So I'm going to plot, first of all, it's going to go through 50, and then at 55, I'm going to have 2. And I can see that each square is going to be worth 2, so it's going to be here. Sorry, pen's not quite behaving right now. Come on. Better. Thank you. So cumulative frequency for 60 is going to be 9. Okay, that's just underneath the 10. And then for 65, it jumps to 24. 65, 24. For 70, we get 55. And then finally, our highest is 75. And that takes us up to 60. Just make sure it goes through all the points. Oh, yeah, come on. And they haven't actually extended it here, but so I'll stop it there. But you could carry it on if you want to. All right. Find the median length of a honey badger. So similar to before, the position is going to be 30 because I've got 60 honey badgers. I'm going to halve that to give me the 30th. And actually we see that they have very similar, well, they basically have the same median. I get it as I'm going with 66. Find the interquartile range. Remember, that's the upper quartile minus the lower quartile. So 60 divided by 4 is 15 again. We're going to get 15 and 45. So that looks like 68 minus 62, which is 6. Diagram shows the distribution of lengths of European badgers. So I should maybe label it at this point. I've got my European badgers in red, and I've got my honey badgers in blue. But it's like direct comparison now. We can see very similar sort of thing going on. Compare the distributions of lengths of honey badgers and European badgers. And finally, comment on the suitability of using cumulative frequency diagrams to compare these distributions. So have a think about this. There's actually quite a few answers, and I'm going to show you the answer from the mark scheme that they give. So actually, I'm just going to check. So yeah, they got the same median as me. I should have maybe have written centimeters, to be fair. They got 6.5 centimeters for the interquartile range. I think I'd be okay with mine. But I should have written it down in terms of centimeters. And then the distributions have very similar medians. I don't think you need to do any additional calculations to show that. I mean, we can see that's the case. And they're going to also have similar quartiles if you read off. Not quite the same, but they're going to be close. And that's a useful comparison. They're going to have a similar interquartile range as a consequence. The maximum length of the European badgers is greater, as we can see. And you might say the minimum length of the honey badgers is smaller. You know, that's another thing you could write down. And then just be aware that we don't have exact values. We don't have any raw data, so we can't compare the median, quartiles, or range. I would say exactly, to be honest. Like, I think we can, you know, we can do a decent job, but I suppose, yeah, you can't be completely reliable and you can't guarantee accuracy. So just be aware of that. Just to summarize then, we've looked at how to plot cumulative frequency graphs. We took some time on it in this one. I talked about how we plot the upper boundary and the lower boundary for the first point. We connect it up as a smooth curve in general, could use a straight line. We can look at less than values for it and more than values. We can also look at sneaky ones where you have to figure out what's going on. If it's 3/4 past the test, it'd be 1/4 failed. It's be a quarter below. That's what we're interested in here. So it's just like read the question and understand the context. We also then we did some similar sorts of things. Looked at the shortest lifetime of a bulb, and then we brought in the median, the interquartile range, discussed them briefly, just a reminder about them. And finally, we've done a comparison question. Okay, hopefully you're feeling happy about cumulative frequency. Make sure that you can do these things. I'd say the comparisons is actually, it's really important to be able to look at these sorts of things. So well done, keep practicing.